Find the second derivative using implicit differentiation. This y double prime means second derivative. We have the equation x equals cosine y. In order to find the derivative, we will need to use implicit differentiation, and that tells us the following. We can take the derivative of both sides of both variables, both x and y, just like we would if we were finding the derivative of x. So on the left side, the derivative of x by power rule gives us 1. And on the right side, it's almost like we're doing a little chain rule with the cosine being the outside function and the y being the inside function. So the chain rule states we will take the derivative of the outside function, which is negative sine. The derivative of cosine is negative sine, and we will leave the inside alone. And to that we multiply the derivative of the inside. The derivative of the inside, which is just y, is y prime. Now we just need to solve for y prime. And when you do that, we can divide both sides by negative sine y, divide by negative sine y. That cancels with this, and we're left with y prime equals 1 over negative sine y. This is just the first derivative. We need to find the derivative again, so we end up with a y double prime over here. And then we would also need to take the derivative of this side. And it looks like, as is, we would need to use the quotient rule in order to find the derivative of 1 over negative sine of y. However, using trigonometry, we can rewrite this as negative cosecant y. So instead of using quotient rule, we can use just the rule that negative cosecant of y equals negative cosecant cotangent of y. So y double prime, again taking the derivative of this thing gives us y double prime, and then I'll take the derivative of this thing here. So that will equal positive cosecant y cotangent y, and we're back in that idea of an outside function being the negative cosecant and the inside function being y. So we have to take the derivative of the inside function, and the derivative of y, if we treat it like x using the power rule, would just be 1. But since, again, we are taking that derivative of y, we need to write the y prime right afterward. With that being said, we can rewrite our derivative, our second derivative, y double prime equals cosecant y cotangent y, and instead of writing y prime, I want to write 1 over negative sine of y. We can't have a second derivative in terms of y primes. We can only have the variables x and y over here on the right side. So again, instead of y prime, I'm going to write 1 over negative sine y. From the previous slide, we have the second derivative being equal to cosecant y times cotangent y times -1 over sine y. The only thing we need to do now is clean this up a little bit, and that mainly lies in this part right here. We know that -1 over sine y is the same thing as negative cosecant y, with the rest of our derivative staying the same. This allows us to combine this cosecant y and this cosecant y to a negative cosecant squared y cotangent y. Here is your second derivative with implicit differentiation.